And welcome to my mathematics lessons. This time we're going to talk about volume. For this topic I actually prepared a lot of IGCSE past papers questions because it's very common to see it in past papers. And let's get started. So here's the formulas that you guys need to know. Actually, not all of these formulas have to be memorized by you, because some of them will be mentioned in the past papers. You will see the examples below. So, for example, Prism. Okay, so Prism is very useful to know. Volume of Prism is also an easy formula. It's just the area of cross-section. Whatever the cross-section is, you know that there's different prisms. There's a triangular prism, for example. Then there's a rectangular prism, which can be called a cuboid. All right, all kinds of prisms. All right, so even the cylinder is technically a prism, right? So the formula, general formula for prism is area of cross section. In this case, this is the cross section. So cross section is this part which is kind of like elongated. It's this 2D shape. Cross section is this 2D shape which, when elongated, this 2D shape forms the prism, like here in this case, yeah? So in this case, the cross-section is the trapezium, but again, as I've told you, it can be anything. And basically, the area of prism equals to area of cross-section times length. So as long as you know how to find the area of cross-section, you are basically covered, right? And cylinder, by analogy, it's basically a circular prism, so it's just area of the circle times this kind of like a height or length. It could be, depending on how you put it, right? If you just like, if you put it like this, then it's length. If you kind of put the base on the bottom, it becomes kind of like a height, yeah? Anyway, very easy formula. Again, area of cross-section times length. Okay, next formula is for pyramid. This formula will be mentioned in most of cases, but still, this one is good to know. So volume of pyramid is 1/3 times base area times height. Okay, and for cone, the formula is also very similar to the pyramid, so this is why they are grouped together. So for cone, you notice that the formula is 1/3 times area of the circle, which is the base in this case, and then times height. So basically, both for pyramid and for cone, the formula is 1/3 times base area and then times height. That's the formula. Okay, next is the sphere. So that's the formula which people always forget. I forget it myself sometimes. And but the good thing is, even if you forget it, this formula is always going to be mentioned in the past paper. So the formula is 4/3 times pi r squared, pi r cubed, sorry. That's the formula for volume of the sphere. All these formulas can be derived. If you're interested, you can look up more into this material. So they don't just come from nowhere. These formulas can be explained quite easily, but I'm not going to go into the detail. Let's just take a look at some examples. And here is the first question, again from past paper. So they have a pyramid. So diagram shows the pyramid on a horizontal rectangular base. ABCD, the diagonal of ABCD meets at E. The diagonals meet at E. P is vertically above E. So AB is 8 centimeters. BC is 6 centimeters and BC is 13 centimeters. First of all, we have to find a PE. That's the height of this pyramid. You have to find it. And then we have to find the volume of this pyramid. And notice that we are already given the formula here. So as I've told you, in most cases, you will be given these formulas for volumes in most cases. The only case like a prism, in lots of cases the volume of prism is not mentioned. So again, let's just go back for a second. So guys, make sure you remember this formula, because this one is often not mentioned, so you have to memorize it. Okay, so let's get started. So first of all, we have to find PE, the height of the pyramid. I'm going to kind of mark it like this. This is what we are looking for. We are looking for PE. All right. Okay, so this is rectangular pyramid. To find PE, actually what we need to do is we can use we can find it by using Pythagoras theorem and by using this rectangle. So you see, triangle. We can use the triangle PEC to find PE, but we only have one side. We need two sides to use Pythagoras theorem. How do you find this side? Quite easily, we use another triangle. So here's another triangle here, ACB. We can use this triangle to find AC. So we can see that AC squared equals to, so remember again, the Pythagoras theorem is basically like this. So hypotenuse squared equals to two other sides squared added together. Okay, so AC squared we could say is equal to, let's make it like this. I'm going to move my face out of the screen a little bit. Okay, so AC squared equals to 8 squared plus 6 squared. Very classic. So it's going to be AC squared equals to 64 plus 36 equals to 100. So AC equals to square root from 100 equals to 10. So this side AC is equal to 10 centimeters. Let me erase this. So AC is 10 centimeters. Then we know this is ABCD is a rectangle. So I'm going to make a small plan here, ABCD. Sorry, not like this. C is here, D is here. So AC, this is 8, this is 6, and AC is 10. But we know that diagonals of rectangle cut each other in half. So half of this diagonal is going to be 5 centimeters. So EC is 5 centimeters. All right. Then PE, we could say that actually PC squared, because it's a hypotenuse in this case. So we have, again, we have a right angled triangle here, you see? So the right angle is here, and this is E, C, and P. This is 13 centimeters, this is 5, we have to find this side. Okay, so we can say that PC squared equals to EC squared plus PE squared. Alright, so PC squared is 13, so 13 squared equals to EC squared, which is 5 squared, plus PE squared, something we don't know in this case, we have to find it. So we can say that PE squared equals to 13 squared, 169, minus 25 equals to 144. Then a square root of it is square root of 144 equals to 12. Again, I'm really bad with like managing space, so I will have to erase this part from here. Yeah, let's just, I want to save it still. So I will keep it in, at least in my clipboard. Okay, so PE equals 12, and that actually answers the part part A of this question. Now let's do a part B. Let's do part B. Calculate the volume of the pyramid. So volume is given by the formula. So volume equals to 1/3 times base area times height. Yeah, and all of these are easy to find. So 1/3 base area. We see that this is the base. I already did a small sketch. So A, B, C, D. This triangle is the base. Area of rectangle. Area of rectangle is 8 times 6. So which is to 8 times 6 here, and then times height. The height is our PE, which is a 12 in this case. So 12. Yeah, we can cancel this a little bit. We can have 2 left here. So 8 times 2 and then times 12. 16 times 12 equals to what? Equals to 192. So volume of this shape is 192. Don't forget about unit. The unit in this case is centimeters cubed. Okay, so that's it. That's it. This question is done. PE is 12. By the way, oh, don't forget, I almost forgot about this. P is 12 centimeters. Don't forget about the units, please. You see, I do the same mistake. Don't forget units. All right. So PE is 12 centimeters, and the volume is 192. Don't forget, it's centimeters cubed. So the units of volume are centimeters cubed. Don't forget about this stuff. Okay. And here we have like a small, this is actually a fragment of question, not the whole question. But anyway, it's quite interesting, I think. So the diagram shows a prism ABCDEF. The cross section is a right angle triangle BCD. BD is 10, BC is 5.2, and ED is 18 centimeters. work out the volume of the prism. Let's do it. So let's do it. Let's work out the volume. Remember the formula for volume. So volume, we know this equal to volume of prism is base area, or we could say the cross-section area. But I prefer the base term, base area times height. So in this case, this is the base. You see, it's a little bit confusing because normally the base is on the bottom, but basically base is whatever the prism is named after. So this is a triangular prism, so the base of this prism is going to be a triangle, as you can see. How do you find the base area? Well, actually some things are missing in this case. To find area of triangle, particularly of a right-angled triangle. So we know that area of triangle is just equal to 1/2 times a base times height. In this case, the base is missing, right? We don't know the side, but actually it's quite easy to find. So DC is equal to, again, by using the Pythagoras theorem, I'm not going to go into detail, but it's just going to be equal to hypotenuse squared minus the other side squared. So dB, so this is hypotenuse, minus the other side squared, and all of this in the square root. Let's figure this out quickly. So again, 10 squared minus 5.2 squared. That's 8.54. I think that's enough of, yeah, just 2 decimal places is always enough. And then area of this triangle is equal to, so this could be the base and this could be the height in this case, right? So it's going to be 1/2 times base, which is 8.54, times height, which is 5.2. Again, the calculator is going to help us here. So 1/2 times 8.54 times 5.2. 22.204. Let's just write it as 22.2. 22.2 centimeters squared is the area in this case. Okay, and finally base area times height. In this case, we know that a base area is 22.2 and the height is this thing. Height, or we could say the length. Height slash length, yeah? So 22.2 times 18. Again, this is our base area, area of cross-section, times the length of this prism, all right? Which actually it makes perfect sense. If you think about it as in kind of like a salami or something, then basically we have one salami. Let's say the area of this salami is hypothetically 10 centimeters squared. And if we keep stacking these salamis, right? So if we have 2 of them, the area becomes double, the 2 slices of salami, right? If we have 3 slices of salami, the area becomes triple. If we have 4 slices and so on, we just keep multiplying the area by whatever amount of slices we have. So let's say our salami has 10 slices on top of each other, then the total area is, so for one of them is 10 centimeters squared, and because we have 10 slices, we can do 10 centimeters squared times 10, which will give us the total volume of 100 centimeters cubed for this big piece of salamis stacked on top of each other. So the prism works in the same way as the stack of salami, right? We just have this triangle, which is kind of stacked on top of each other many times, like this, like a slices of cheese or something, just slices of something. So anyway, 22 times 2, 22.2 times 18 is equal to 399.6. 399.6. Don't forget about the unit, centimeters cubed in this case. And that's it. That's it actually for volume. So we had 2 past paper questions. Again, please remember the formulas. Some of them you have to memorize, particularly the Prism formula. You have to memorize this one. All right. The other ones you will probably be given in the past papers. So yeah, that's it for this lesson. Have a nice day, everyone.